Question 10 now we're at is measurement, geometry, and trigonometry. So it tells us that P, Q, R, and S are 4 points on the circumference of the circle. As shown, an angle QRS is 58. Using the geometrical properties of a circle, find the angles that they give you, stating reasons for your answer. Now first, angle at the center is twice the size of the angle of the circumference when subtended by the same chord. So angle at the center, so this angle right here is going to be angle at the center is going to be twice of 58. 2 times of 58, which is 116. That's 116. All right. I don't know why I don't wanted to find that, but I just wanted to write that out of the way. Now the question says, find angle SPQ. SPQ, so this angle. Now first and foremost, guys, RSPQ forms a cyclic quadrilateral, and opposite angles in a cyclic quadrilateral sum to 180. And so angle SPQ is equal to 180 minus 58. Question is so easy. Angle SPQ is equal to 180 minus 58, which is equal to 122 degrees. 122 degrees. All right, that's angle SPQ. 122 degrees. What's the reason? You can tell him that SRQP forms a cyclic quadrilateral, and so opposite angles in a cyclic quad sum to 180. All right, and so what we're saying then, so 58 degrees plus angle SPQ equal 180. So that's the reason that we use, and that's going to give us angle SPQ. Nice and easy, soft. They want angle OQS. How do we find angle OQS? Angle OQS. Angle OQS is this angle inside here. Now angle OQS is going to be equal to, now this is an isosceles triangle. How do I know that this is an isosceles triangle? Because OS and OQ are both radii. And so this angle is equal to this angle. And so angle OQS is going to be equal to, let's go do that now. Angle OQS is equal to 180 degrees minus 116 degrees. 180, wait, angle OQS is equal to a half times 180 minus 116 degrees. So angle OQS works out to be 180 minus 116 divided by 2, that's 32 degrees. That's angle OQS. That's angle OQS. Now that we get angle OQS, we can clearly state that angle OQS is equal to 32 degrees. Then what else can we state now? Give them the reason. So first, how did we come about that 116 degrees? We can tell them that angle SOQ equal 116 degrees because Angle at the center is twice the size the angle at the circumference. Angle at the center is twice the size the angle at the circumference. All right, since angle at the center is twice the size the angle at the circumference, and so that's how we get this to be 116. What's the next reason now? How did we get it to be 32? Why is it a half of 180 minus 116? We can tell them that SOQ is an isosceles triangle, and so angle OSQ is equal to angle OQS. All right, that's why it's 32. Nice and easy, soft. All right, so question part B now, it says a ship leaves port A and it will sail 52 kilometers on a bearing of 44 degrees. And then it sailed to port B. And then the ship changed direction and it sailed to point C, 72 kilometers away on a bearing of 105. Then label diagram. So the angle right here is going to be 44 degrees, because them tell us clearly the bearing of B from A is 44 degrees and the distance is 52 kilometers. That's the distance. Then the next thing that they tell us is that it changed course to go from B to C, and the bearing of C from B is 105 degrees. And they tell us that the distance from B to C is 72 kilometers. So this is the diagram that they want us to label. Next part now, it says determine angle ABC. To find angle ABC is this angle here, so we want. So look how we're going to find angle ABC. To find angle ABC, let's zoom in a little bit. We're going to split this right here. All right, I'm going to draw a 90 degree going down. Split it. Angles on a straight line is 180. And so this portion is equal to 75, because angles on a straight line is 180. Now, how are we going to find this piece? This is how we're going to find this piece. So if I were to go again and break this up going across to make this be 90 degrees and continually going up, then this would be 90 degrees right here. If this angle is 90 degrees, then the angle right here is going to be 44 plus 90 is 134. So this has to be 46 to make the angle sum to 180. So this is 46. Now, if this angle is 46 right here, right, I can split this going across. And if this angle is 105, then this little piece in here so is 15. If this little piece in here says 15 degrees, angles on a straight line is 180. And so if this we split it in a straight line going across 15, 75, 46, and this angle should be 180. So what is this angle going to be equal to? That's 44. We didn't even have to do all of that. We could have looked at it and said alternate Z angles are equal. So this angle is 44 degrees. So now that this angle is 44 degrees, angle ABC is equal to 44 plus 75. That's angle ABC. Angle ABC is equal to 44 plus 75. Nice and easy. 44 plus 75, as we know it, is 119. So angle ABC is 119 degrees. Nice and easy, soft. Now continuing, calculate the distance AC. To find the distance AC, we're going to have to use cosine rule. We have two sides, and an angle in between them. So we use cosine rule. So using cosine rule, we're going to get AC squared is equal to the first length, which is 52 square, plus the second length, which is 72. I'll square it. So 52 square plus 72 square minus 2 times 52 times 72 times the cosine of the angle between the two lengths. And the angle between the two lengths is 119. So it's been multiplied by the cos of 119. 119, 119. Someone call the police. So AC squared works out to be, we're going to work out all of this, and that's AC squared. 52 squared plus 72 squared minus 2 times 52 times 72 times the cos of 119. That's 11,518. 11,518. And so when we square root both sides, we get that AC is equal to the square root of this answer. And I get 107 kilometers. 107 kilometers. That's AC. 107 kilometers. Now that AC is 107 kilometers, we're nice. So we can go back around here now and label that. So the distance AC is 107 kilometers. So we have the distance AC, which we know is 117 kilometers. 107 kilometers. All right. And now what are we required to find? Let's look at what next they want us to find. So the next thing that they want us to find now is show that the bearing of A from C is 216 degrees. Show that the bearing of A from C. The bearing of A from C is going to be equal to this angle all around here. So now to find this angle all around here, I can say it's equal to 360 minus this angle right here plus the angle inside the triangle. The angle BCA, I'm going to call that theta. Now this angle outside here is 75. How do I know that it is 75? Z angles are equal. So if this is 75, this out here is 75. So 360 minus 75 plus theta will give us the bearing. So let's use that now. That the bearing of A from C is equal to 360 degrees minus theta plus 75. Minus in bracket theta plus 75. So how are we going to find theta now? To find theta, we can use cosine or sine rule. Yes, we can. We can use cosine rule or sine rule. Let's go ahead and use sine rule. By sine rule, it is telling us that the sine of theta over the angle that corresponds to this theta is 52. So sine theta over 52 is equal to, using this known side that we know, that's 107 over the angle that we know right here, which is 119. So it's equal to sine 119 over 107. That's sine rule. Sine 119. Now that we know that it is sine 119 over 107, all we need to do is just transpose to make theta the subject. So to transpose and make theta the subject, we're going to eventually get that theta is equal to sine inverse of 52 times sine 119 over 107. So theta is 52 sine 119, call the police, 119 over 107. Now we work this out, you put that in your calculator, I am getting 52 sine 119 divided by 107, and I take sine inverse, I'm getting 25 degrees. Theta is equal to 25 degrees. Now that theta is equal to 25 degrees, now I can go ahead and find the bearing. Continuing, so the bearing is equal to 360 minus, in reality, theta was actually 25.15 or 25.2 plus 75. And so when we subtract them, we're getting 360 minus 25.2, and subtracting them, we get that that is equal to 360 minus that is 259.8, which is equal to 260 degrees. And that's how we work that out. Nice and easy, soft.